Hello, grade 3. How are you? Hope you're fine. Let's start chapter 8, lessons from 71 to 75. It's about fraction. What is the fraction? To know what is the fraction, let's listen to our story. Here we have mom and her two kids. She baked a large pizza. It's a whole pizza. Okay, it's whole pizza. She wants to divide this pizza equally between her two kids. So she can't cut it like this. She can't cut it like this. She can't give one more than the other one. So she must divide it equally between them. So each one will take a half. The girl will take a half and the boy will take a half. So fractions are equal parts of a whole. What we did now is called fraction. So fractions are equal parts like our equal parts of pizza, equal parts of a whole. If I have my whole pizza here, this whole pizza is called one whole. I didn't divide it now, okay? So this is one whole. But if I have two kids and I want to divide it between them equally. So each one will take one half, and it can be written like this. If I have three kids, so I will distribute it equally. The first kid will take pizza like the second and the third. All of them will take same amount of pizza equally, okay? So it will be divided equally. Each one will take, they are three kids. So each one will take 1/3, and it can be written like this, 1/3. If I have 4 kids and I want to distribute my whole pizza equally, so I have 4 kids, I will divide it into 4 equal parts. So each part will be 1/4, or 1/4, I can pronounce it quarter in American pronunciation or quarter in a British pronunciation, okay? But I will say quarter in American pronunciation. So each one will take quarter, and I can write quarter like this, 1/4. If I have 5 kids and I wanted to distribute my whole pizza between 5 kids equally, so each one will take 1/5, and it can be written like this, 1/5. If they are 6 kids, I will distribute the same pizza between them, and each one will take 1/6, and it can be written like this, 1/6. If they are 7 kids, each one will take 1/7, 1/7. If they are 8, 1/8, 1/8. If they are 9 kids, each one will take 1/9, 1/9, and it can be written like this, 1/9. If they are 10 kids, each one will take 1/10, 1/10, and it can be written 1/10. How to express the fraction? How can I write the fraction? The first type, I have fraction as a part of whole, like what we did in our pizza. Our pizza was whole pizza, and I divided it into equal parts. So I want to express the fraction as a part of whole. Part of whole. But now I'll give you another example different than pizza, okay? If I have a chocolate bar like this, chocolate bar like this, okay? It has 3 parts with brown chocolate and 2 pieces of white chocolate. So 3 pieces or 3 parts of brown chocolate and 2 parts of white chocolate. I want to find the fraction of brown parts. So I will write my fraction like this, 3/5. How did you get it 3/5? 3 here is referring to the number of colored parts. I want to know the brown parts, brown parts. So how many brown parts here? 1, 2, 3. So this 3 is the number of colored parts, and it's called numerator, 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 okay? And in the bottom here, I will write 5. How did you get 5? 5 is called denominator, denominator, and it's referring to the total parts in whole, the total parts in whole. So how many total parts? Brown and white, colored and not colored. Let's count together. 1, 2, 3, 4, 5. So I have 5 total parts, 5 parts in total, okay? So I write in the top, I write on the top numerator, numerator, numerator is the number of colored parts, the number of colored parts, and I put the fraction bar. This dash is called fraction bar, and in the bottom I write denominator, 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 denominator for total parts, colored and not colored, brown and white, okay? It can be read as, how to read 3/5? I can say 3/5, 3/5, 3/5, or 3/5, or 3/5, or 3 divided by 5. I will tell you how to read this later, inshallah, okay? So 3/5 or 3/5, okay? I'll give you now another example. So we studied fraction as a part of whole. I get the part of the whole chocolate bar. Now I want to find the fraction as a part of set. If I have a set of balls like this, set of balls, set of balls. I have yellow balls and white balls. I want to know the fraction of yellow balls. Okay, so how can I write it? What should I write in the numerator? Up. What should I write up? Here we said we write on the top the number of colored parts. I want to know the fraction of yellow. So in the top, in the numerator, I will write how many yellow balls. 1, 2, 3, 4. So I will write 4. 4 over what? The total parts. The total parts, which are 1, 2, 3, 4, 5, 6, 7. So 4 over 7. 4 over 7. I have 4 yellow and 7 the total balls. I can read it 4 over 7 or 4 sevenths. 4 sevenths. Let's solve our math book. Lesson 71, the correct part. Read the questions below and circle the cookie that answers the question. Question A. If two people want to share a cookie fairly. Fairly means equally. I have two people and they want to share a cookie fairly. Fairly means equally. Which image shows how they should cut the cookie? I have first image here. Do I have here two equal parts? They are two people. Do I have here two equal parts? No, I have one small and one big. So they are not equal. But number 2, I have two equal parts. So I will circle it. Question B. If I have 4 people want to share a cookie fairly. Again, fairly. It means equally. Which image shows how they should cut the cookie? The image 1 or the first image. Do I have 4 equal parts here? No, they are not equal. So I will choose number 2. They are equal parts. Question C. If 3 people want to share a cookie fairly again, which image show how they should cut the cookie? I have 3 people. So this or this? Sure, number 1. Draw lines. Here he wants me to draw lines on the cookie below to show where you might cut and share it fairly with 8 friends. I have 8 friends. They should eat this cookie. So I must divide it fairly or equally. Like this. Let's go to the apply part. Answer the following questions. Circle the shapes that are divided into equal parts, fair shares. Fair shares. It means equal parts. Fair means equal, okay? So, the first shape here, do I have equal parts here? Yes. The second shape, do I have equal parts here? All parts are equal or not? No, they are not equal. The third shape, yes, they are equal parts. Number 2, divide the following shapes into the fractional part listed below. I have here a circle. I want to divide it 4 equal parts. 4 equal parts, it means fourths. It means fourths. So I will divide it like this. 6 equal parts. 6 equal parts means sixth. Sixth. So I will divide it like this. Number 3, match the picture of the fraction to its name. The first shape here or the first picture here, I have 2 parts. So 2 parts in fraction is called what? We said before half and half. So I have here two halves. Two halves. Yes. The second picture, I have a circle here. It's divided into four equal parts. Four equal parts. It means what? Huh? Fourths. Fourths. Here I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 equal parts. So they are eighths. Eighths. Here I have 6 equal parts. Sixth. Sixth. Here I have 3 equal parts. So they are thirds. Thirds. Question number 4. Circle the shapes that are divided into equal parts. Write sentence telling what equal parts mean. Now, the first shape, this triangle, is divided into equal parts? Yes, so I will circle it. The second shape is divided into equal parts? No, focus here. This part is not like this, and this part is not like this. So it's not divided into equal parts. Here, this shape has 3 parts. Are they equal? Yes, so I will circle it. This shape divided into equal parts? No, focus here. This part is not like this, is not like this, is not like this. So I will not circle this shape. The last shape, this circle, divided into equal parts? Yes. Now let's write sentence telling what equal parts means. When I divide the whole shape into equal parts, this is called fraction. Fraction. Now let's move to the challenge part. Yasser wanted to share the cake below with 3 of his friends. Here is how he cut it. So we have now Yasser and 3 friends. His friends told him that would not work because there were 4 of all of them altogether. We have Yasser and 3, so all of them are 4. So it's not correct. So Yasser took one piece and cut it into half. One piece of this cake, or one piece of these thirds, and cut it into halves. And he said, now we have fourths. Fourths it means 4 equal parts. Do we have 4 equal parts if we took one piece of these pieces and cut it into halves? So, do I have equal parts now? Was Yasser's thinking correct? Why or why not? And explain your thinking below. If disagree, you can draw a solution. Focus with me. They are 4 friends, and this is not correct. If he cut 1/3 of these thirds into 2 parts, they will not be the same. So it's not correct. We should cut the cake into 4 equal pieces to have 4 fourths. It will be like this. If I have this cake, I will cut it like this. Okay? Now the math journal. Reflect on your learning about fractions today. Then answer the question below. and write your definition in the box. You can use words, numbers, pictures, or examples. What is the fraction? Fractions are equal parts of whole. Equal parts of whole. Like we did in the last or in the previous question, we should divide the whole into equal parts. So fractions are equal parts of whole. 22. The connect part. Amira folded 3 pieces of paper into halves. I have here 3 papers. Okay, she folded them, each one into 2 halves. Here is what they looked like. Okay, her brother Ihab told her only the first one showed halves. Only the first piece of paper showed halves. But they are not halves. Do you agree with him or disagree? Huh? Do I have the first piece only divided into halves, and these are not halves and these are not halves? No, I disagree, because all of these papers are cut into 2 equal parts. All of them are 2 equal parts. As we said before, if we have the whole pizza and we divided it into 2 equal parts, so each person or each kid will take 1 half here and 1 half here. So the whole one contains 2 halves. 2 halves. 1 half here and 1 half here. They are 2 halves, okay? And if we divided the whole pizza into 3 parts, 3 equal parts, so each one will take 1/3. I have here 1/3, 1/3, 1/3. So the whole one contains 3/3. 3/3. If we divided it into 4 equal parts, so each part will be fourth. 1/4 here, 1/4 here, 1/4 here, and 1/4 here. So the whole pizza now contains 4 fourths. 4 fourths. So the one whole contains 2 halves, as we said here. And the same one whole contains 3/3, 4 fourths, and so on. So how many fifths in whole one, or in one whole? 5 fifths, 6 sixths, 7 sevenths, 8 eighths, right? Okay. And we can write it like this. The whole one like this. It contains 2 halves. 2 halves. 2 over 2. 3/3. 3/3. Or 3 over 3. The whole one, 4 fourths. 4 fourths. Or 5 fifths. 5 fifths. And so on. Here in the lesson 72, the apply part, he wants me to write the names of fractions here. This is what, if we consider this as chocolate bar, okay? The first chocolate bar is what? It's one whole, okay? It's one whole. It's not divided to any parts, okay? But the second bar is divided into 2 equal parts. So this is half and this is half. Let's write it. Half, half. And we know that we can write half as 1 over 2. Okay? This bar is divided into three parts, three equal parts. 1, 2, 3. So each part is called third. 1 over 3. Third, third, third. So the one whole contains 3/3. 3/3. Okay? Now, this bar is divided into four equal parts. 1, 2, 3, 4. So the one whole equals 4/4. 4/4. Fourth, 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 fourth. And the plural of them, 4/4. 4/4. Here we have 1, 2, 3, 4, 5, 6. 6 parts, 6 equal parts. So each part will be 1 over 6 or 1/6. 1/6. So we have here 6/6. And here 1, 2, 3, 4, 5, 6, 7, 8. We have 8 equal parts. So each one is 1/8. 1/8. All of them are 8/8. 8/8. 73. The connect part. Divide each clock face into the fractional parts that are listed below the clock. The first clock face here, we have the word halves under it. The word halves. So I want to divide this clock face into halves. Halves. So the whole one contains how many halves? Huh? 2 halves. 2 halves. 2 over 2. So it will be like this. This is half and this is half. You can divide it into any halves. You can take a line between 9 and 3. From 9 to 3, it's half here and half here. If we started at 12 o'clock, we will move to 6 to be half. So this is half and this is half. The next one, fourths. Fourths. So I wanted to divide this this clock face into fourths. How many fourths in the whole one or in the one whole? How many fourths? 4/4. So it can be divided like this. If we started from 12, so we can make it like this. Thirds. Thirds. How many thirds in the one whole? 3/3. So it can be divided like this. Let's start with the apply part. Here we have some stories or some problems. We want to solve it using fraction models. Question number 1. Nuran has a long loaf of bread. She wants to share it with 2 of her friends. Focus here. We have just one long loaf like this. She wants to share it with what? 2 of her friends. 2 of her friends. So we have Nuran and the 2 friends. We will cut it between Nuran and 2 friends. So we have 3 persons here. Nuran and 2 friends. So we will cut it into how many parts? 3 parts. Because we have 3 persons. And each person will take 1 over 3. He will take or she will take 1 part from 3 parts. So it will be 1 out of 3 or 1 over 3 or 1/3. Question number 2. Rami has a long piece of wood. He needs to cut it into enough pieces to share it with 7 friends. So we have Rami and 7 friends. Share with, it means Rami also will take a part. So we have Rami and 7 friends. How many total persons now? We have 8 persons. So he will cut this piece into 8 parts. And each friend or each person will take 1/8. 1 part from 8 parts. 1/8 or 1/8. Question number 3. Samir had a candy bar. Samir had a candy bar. He took 2 days to eat it and ate the same amount each day. So he cut it into 2 parts and each day he ate the same amount. Monday he ate 1 piece. On Tuesday he ate 1 more piece. Which of your fraction pieces best match? We cut it or we divided it into 2 pieces. Each day he will eat 1/2, 1 out of 2, because they are 2 parts and he will eat only 1 part. So 1/2 or 1/2. Question number 4. To make a garage for his toy truck, Kamal bends a rectangular piece of cardboard in half. Okay, so he cut this rectangular piece into half. Okay, half and half, 2 halves. Okay, then he bends each half into half again. So I have here a half and here a half. He cut this half into halves and this half into halves like this. This was half and this was half. He cut this half into 2 parts or 2 halves and this half into 2 parts. The total parts are 4 parts. So each part will be 1/4. 1/4, 1/4, and 1/4. Question number 5. Kamal bends a different piece of cardboard in thirds. Yeah, we have now a different piece of cardboard. He cut it into thirds. Okay, thirds, it means 3 equal parts. Then he bends each third into half again. Focus here. We have 1/3 here, 1/3 here, and 1/3 here. Then he cut each third into half, like this. So the total parts are 1, 2, 3, 4, 5, 6. Okay, or we can say we have 3 parts in the first, then we cut each part into halves. It means 2. 3 times 2 equals 6. So we have 6 parts. Each part will be 1/6. 1/6. Move to the challenge part. In this part, we need to think more and focus more to solve it. The challenge part. Number 1, if Kamal had flooded the piece of cardboard from problem 5 in half again. Focus with me. It was like this. okay, one piece like this, and he divided it into thirds. So each part was third, okay? Then he divided each part of thirds into another half. So they became 6 parts. So each fraction now 1 over 6. 1 part over 6. Now he wants me to know if he flooded the piece of cardboard into half again. I will take this 1 over 6 and flood it into halves again. So how many pieces do we have now? They were 6, and we flood each part into 2 parts again. So it will be 1 over 2. 1 over 12, sorry, 1 over 12. 1 over 12. Question number 2. Mona had a long piece of string like this. She cut it into 8 equal parts. 8 equal parts. Like this. Then she gave 3 of the parts to her sister. 3 of the parts. This was the share for her sister. And 1 part to her brother. Like this. What the fraction of a string does Mona have left? Left means we will subtract. We will subtract what she gave to her brother and sister from the total parts. So she gave them 4 parts. So 8 parts minus 4 parts that she gave to her sister and brother. She will have 4 parts left with her. Let's move to math journal. Reflect on your work you did to solve the story problems today. Pick one of your fraction strips and write a story problem that would match the strip. Draw the strip below the story. You will pick any strip like this or previous strips, okay, in the previous problems, and you will write a story problem here that represent our strip, okay. So, and you will draw it here. This will be as more practice for you. Now let's start a new topic. Unit fraction. What do we mean by unit fraction? Unit means 1. So the unit fraction is a fraction that has 1 as a numerator. What we said about numerator? Numerator is the numbers on the top in the fraction. So the numbers on the top in the fraction is called numerator. When it's 1, when it equals to 1, it means this fraction is a unit fraction. Here we have some unit fractions. I have here half, 1 over 2. The numerator here is 1, so it's unit fraction. Here, 1 over 4, or fourth, or quarter. This quarter, unit fraction or not? Yes, it has 1 in numerator. Here also we have 1/8, and we have 1 in the numerator, so it's unit fraction. Here we have 1 over 16, so this is unit fraction because numerator is 1. Here, non-unit fractions. Non-unit fractions. Why? Because here we have 2 over 4, 2 over 3, 3 over 4. Here we have numerators different than 1. The numerator here is 2. Numerator here is 2. Numerator here is 3. So we don't have 1 in numerator. So this is non-unit fraction, or it's not unit fraction. So this unit fraction and this not unit fraction. Now let's start with lesson 74, the connect part. Here we have an error in solving this problem. The problem was sketch a rectangle, divide the rectangle into 4 equal parts, and label each part. He wants me to divide this rectangle into 4 equal parts. And it's right. The student did it correctly. Here we have the rectangle which is divided into 4 equal parts, but he wants me to label each part. Is it right? Is it right? This part is 4 over 4? This part is 4 over 4? No. Each part is only one part out of 4. 1 out of 4. So it's 1 over 4, or fourth and quarter. So what the student did right? The student divided the rectangle into 4 equal parts. But he wrote something wrong. He wrote the fraction of each part as 4 over 4, and it's not right. It's wrong. The right should be the fraction of each part must be 1 over 4, like this. Here we have some circles. In the apply part, we have some circles. Some of them divided into equal parts, and the first one is not divided into any parts. So it's one whole. It's one whole. And the next one is divided into 2 equal parts. 2 equal parts, it means 2 halves. Each part will be 1 over 2, or 1 half. The next circle divided into 3 equal parts. These 3 equal parts, each part will be 1/3, 1 over 3. And the next one, 4 equal parts. So each part will be 1 over 4. The next one, 6 parts. So each part will be 1 over 6. The last one, 8 parts. 8 parts. Each part will be 1 over 8, or 1/8. Let's notice something. When we divided the same circle between 2 students into 2 parts, each student will take 1/2. But here, when we divided the same circle between 3 students, or among 3 students, each student take 1/3. Which is bigger? Which is bigger, the half or third? Half is bigger. When I divide one pizza between 2 kids, each kid will take half, and this half is bigger than third. So we should notice that the half is larger than third. The half is larger than third. And when we split something between 2 people and split the same thing among 3 people, the pieces will be larger for 2 people. Okay, so half is larger than third, and the third is larger than fourth, and the fourth is larger than sixth. Let's move to the math journal. Reflect on your learning about fraction today. Write your response. What is the relation between the size of denominator and the size of fractional pieces as it relates to the whole? Denominator, we said before, denominator is the number which is in the bottom of fraction, and it refers to the total fraction pieces, the total fractional pieces. And the denominator size, the total fraction, is bigger than the fractional piece only, which is numerator. So the denominator, which is the total number, is greater than numerator, which is the one piece only or fractional piece. Now let's move to the apply part of comparing fraction. Compare each fraction and write smaller than, greater than, or equals to. The first question here, half and sixth. We have here the denominators are the same. So the big denominator is smaller one, and the smaller denominator is the biggest one. Yes, it's a crazy fraction. When we have the small number down in the denominator and the bigger number here, so the smaller is bigger. As we did before, we said that if we have one large pizza and we divided it between two persons, and the same pizza we divided it among 6 persons, so which group will take a larger part? Sure, the group of 2 persons, so the half is bigger. Here also we have sixth and third, so the numerators are the same, it's unit fraction. When we compare the unit fraction, the big denominator is smaller and the small denominator is bigger. If we have one chocolate bar and we divided it among 3 persons, and we have the same chocolate bar and we divided it among 6 persons, which group will take bigger or larger piece? 3 persons or 6 persons? Sure, 3, because the smaller denominator is bigger amount or a larger piece. Also here we have one whole. One whole. If you eat one whole pizza, it's bigger, or if you eat quarter pizza? Sure, one whole is bigger. And we said before, one whole equals 2/2 or 3/3 or 4/4 or 5/5. So 4/4 is bigger or quarter? 4/4. 1/3 is bigger or 1/8? Imagine you have now third pizza or eighth pizza. Sure, third pizza is bigger. Okay, third and third, which is bigger? They are the same, equal to eighth or sixth. Sure, sixth. We said if we have the same numerator, so the smaller denominator is bigger. And you can do number 7 and 8 by yourself. Here in question 9, Rania needs third liter of oil and fourth liter of water to make a large batch of muffins. Will Rania use more oil or more water? Third liter of oil is bigger or fourth liter of water is bigger? We said before we have enumerators 1 and 1, so the smaller denominator is bigger. So third is bigger. We have third here and fourth here. The same numerator, so the big denominator is smaller and the small denominator is bigger. Yes, it's crazy. Okay, so Rania will use more oil because we have third in oil. Question number 10. Ashraf needs to cut some wood of a project. For a project, okay? Ashraf needs to cut some wood for a project. He needs 1/8 of meter for the top and 1/6 of meter for the base. Which piece will be larger, the top or the base? We have 8 here, 8 here, and 6 here. We have the same numerator, so the smaller denominator is bigger. So 6 is bigger, which is for base, the largest piece for base. Here we have the challenge part. Your friend Walid says that 1/6 is greater than 1/5 because 6 is greater than 5. Is Walid correct? Sure, no. We said before 1/5 is greater than 1/6. Why? We said before if the numerator is 1 or is the same, so the smaller denominator is bigger. So 1/5 is bigger than 1/6. And also we said if you have a pizza divided between 5 persons and the same pizza divided among 6 persons, so the group of 5 will take larger piece. Measuring mass. Measuring mass, it means to measure how heavy or how light something is. And we said before, we use 2 units to measure mass. Big unit and small unit. The small unit is gram and the big unit is kilogram. We use gram, the small unit, for measuring the light items. Light items like paper, balloon, ring, feather. And the big unit, kilogram, and its abbreviation is kg. It's used for heavy items like chair, car, pineapple. And we know the relation between kilogram and gram. 1 kilogram equals 1000 gram. 1 kilogram equals 1000 gram. The correct part. Circle the correct unit of weight for each estimation. Here we have a box of cereals. It weighs 350 grams or kilograms. Is it very heavy? 350 kilograms, or it's light? 350 grams. Yes, it's light. Grams. Number 2, a watermelon weighs 3 grams or 3 kilograms. It's heavy or light? It's heavy, so it's kilograms. A postcard weighs about 6 grams or kilograms. It's light, so it's 6 grams. A cat weighs 4 grams or 4 kilograms. Is it heavy or light? It's heavy, kilograms. A bicycle weighs about 15 grams or 15 kilograms. kilograms. It's heavy also. A lemon weighs about 58 grams or kilograms? Huh? Grams. It's light. Now let's move to the apply part. Here we will discuss the fraction in different way. Here the fraction, the one whole, will not be one object only, like chocolate bar or one pizza. No, the one whole will be a set or a group of objects. Here we have a group of apples. In letter A we have a group of apples. This set of apples, how many apples in it? 1, 2, 3, 4, 5, 6. So the total objects are 6. And the one item of this set is 1 over 6. Okay? So if I want you to find the fraction of red apple, how many red apples here? 1. 1 out of what? Out of what? In denominator, we write the total number. So 1 over 6. So the fraction of red apple is 1 over 6. Okay? And the fraction of green apples. How many green apples do we have? 5. 5 out of what? 5 out of 6 apples. So it's 5 over 6. The fraction of green apples, 5 over 6. And the fraction of red apples, 1 over 6. Letter B. Sarah woke up on morning and looked out her window. She saw 3 birds sitting on the fence. 2 of them were large and 1 was small, like this. 3 birds, 2 are large and 1 is small. What fraction of the birds were small? I want the fraction of small only. So the total birds are 3, and the total we write down in the denominator. Okay, in the denominator. And the fraction of the small only 1. 1 over 3. 1 small bird out of 3 birds. Okay. Now let's look at the following pictures and answer the questions about set. How many animals are in the set? We have here how many animals? How many animals here? 1, 2, 3, 4. We have 4 animals in this set. 3 dogs and 1 cat. What fraction of the set are cats? How many cats here? Only 1. 1 out of what? Out of 4. We write in the numerator only cats, which is 1. And in the denominator we write all animals, cats and not and any animal different than cats. So the total will be 4. So the fraction is quarter, 1 over 4. Number 2, we have a set here of locks and key. How many objects are in the set? The total objects 1, 2, 3, 4, 5, 6. What fraction of the set are keys? How many keys do we have? Only 1 key. 1 key out of what? Out of what? Out of 6. So it's 1/6. Question number 3. How many objects are in this set? 1, 2, 3, 4. 4 objects. What's the fraction of the set in the rocket? What's the fraction of rocket here? How many rockets here? This red one. One rocket. One rocket out of what? 4 objects. So it's 1 over 4 or fourth. What fraction of the set is the airplane? How many airplanes here? How many airplanes? Just one. One out of what? Out of 4. So it's quarter. Question number 4. Layla picked 8 flowers for her mom. One of them was pink and the rest were red. So we have 8 flowers. One is pink, and let's assume that all of the rest are red. What fraction of the set were pink? How many pink flowers? Just one. One out of what? The total are what? 8 flowers. So it's 1 over 8. Let's move to the challenge part. Draw a set of something in the box, such circles, stars, people. Then write a unit fraction that describes the set. Okay, so here we have some stars and some stars shapes. Okay, we want to know what fraction of the set were stars. How many stars do we have? Just one. One out of what? One out of what? 1 out of 5. So it's 1 over 5. Number 2, write a word problem in the box below about comparing fraction. You can do it by yourself. It's very easy. You can write as we did before. If we have one pizza and we divide it between 3 persons, and if we have another pizza and we divide it among 6 persons, so third will be greater than 6. You can do it, okay? Thank you for watching. Hope you enjoyed it.